Good evening. My name is Stephen Cooper, and I am an algebra instructor at the Columbia College of Missouri in Gurnee. I've been teaching here 5 years, and I teach courses in beginning, intermediate, and college algebra. Most students walking into my beginning algebra class are very intimidated by math. They're either adults who have been removed from the classroom for many years or even decades, or perhaps they're students fresh out of high school who didn't do very well in math. But either way, every student in this class is not very enthusiastic about it. The degrees offered here on this campus are not math or science or engineering related, so nobody is aggressively attacking math courses here. That's made it more challenging for me, but I enjoy the challenge. One of my mottos is that math is fun, and I do my best to make this class fun while still covering all the material. We don't have any time in this course to goof around. It's all business all the time, but it's a fun environment. The reviews I receive from students are overwhelmingly positive, and students who really dread the material still enjoy the class. What I'm going to do here now is go over my little opening monologue to the beginning algebra class. This would be after I've discussed the syllabus and gone over logistics, and before we actually open the book and really get started, I give a little basic introduction to algebra. And I'd like to do that for you now. I'm speaking in front of an empty classroom, but let's pretend there's students out there, and I'm recording holding my cell phone, so it's not going to be the greatest, but bear with me. Here goes. Algebra is all about dealing with unknowns. Dealing with unknowns. And the way we represent those unknowns is by letters of the alphabet. Okay, X is going to be our favorite letter. We'll see Y's and Z's and ABC's, but X is going to be our favorite letter. And it represents an unknown. In arithmetic, there weren't really any unknowns. If I asked you in arithmetic, what is 2 plus 3? That's easy, right? There's no unknown, there's no mystery. We don't even need a calculator for that one. We've got it. Okay? But in algebra, I'm going to ask you, what is X plus 3? Now, who's bothered by the sight of that X? Anybody? A couple of people. Why? What's wrong with it? And I'll answer for you. I know why. Because it doesn't make sense. How do you add the letter X and the number 3 together? It makes no sense at all, right? And I agree with you. It does not make sense if that's how you look at it. But we need to look at it differently. These letters, these X's and Y's and Z's and ABC's, we need to think of them this way. This letter X, it's a placeholder. For an actual number. A placeholder for an actual number. Now later on we'll throw the qualifier in there of real number, and you'll see that word real all over the book, but for right now we're just going to call it actual. Some everyday, ordinary, regular old number belongs in place of that X, and all we have to do is take that number and add 3 more to it. I mean, that's as easy as can be, if we know what X is. Okay, but we don't know what X is at the moment, so we're going to call it a name, and I chose the name X, or I chose the name Y. Okay, I could call it Johnny or call it Susie, but X and Y makes a lot more sense than Johnny and Susie. It's simple, okay? And we're going to use letters of the alphabet to represent these unknowns. There's 3 kind of overall categories of how we're going to deal with these letters, these unknowns. Possibility number 1. Someone will tell me what X is, okay? And X, again, is any unknown letter we're dealing with here. Someone's going to tell me what X is. It's then my job to do something with that information, okay? We call that evaluating an expression. And I'll define expression here a little more properly in a minute, but to evaluate something means we're going to put a value to it. Take what we're given and just turn it into a number. How much is that X plus 3? Put a value to that X plus 3. Well, if all I tell you is X plus 3, I can't put a value to it. Someone has to tell me what x is first. Okay, well, someone's going to tell me x equals 4. Now I can put a value to x plus 3 because x is just holding the place of some actual number, and I've been told the actual number is 4. Now my job is to figure out 4 plus 3. Okay, and I don't even need a calculator for that one either. Look at that. 2 in a row with no calculator. Okay? That's one possibility. Possibility number 2. I have to find x all by myself. Now, that sounds a little more challenging, doesn't it? I have to find x all by myself. No more Mr. Nice Guy. I'm not going to be told what x is. I have to figure it out. The techniques we're going to learn to do that, you'll see, are pretty cut and dry. It's not really that much more difficult. It's not really difficult at all once we've learned it, okay? We're going to call this solving an equation. Equation and expression are not the same thing. And I'll talk about the difference, okay? But that word solving, it's like solving a mystery. Nobody's going to tell me what x is. I have to find x all by myself. I'm solving the mystery of what is x, okay? I have to do that. I'm not going to be told what x is. Possibility number 3. I don't care what x is. I know what you're thinking. This is the possibility for me. Who cares, right? Who's thinking that? Somebody is. I'm serious, though. I don't care what x is because the problem will have x at the beginning. The problem will still have x at the end. I don't have to find x, and nobody's going to tell me what x is. It's just there. It's holding the place. My job here is going to be to simplify something. Okay? It'll have x's at the beginning, very messy, all over the board, and we're going to consolidate and follow some properties and rules and make it look nice and simple. Simplify. If we don't care what x is, we're not going to have to find it. We're not going to be told. Now, sometimes that's a standalone problem. Simplify and walk away. Quite often, however, this process of simplification shows up in the other two, particularly solving an equation. First, we'll simplify the equation, and while we're simplifying, we don't really care what x is. Then we'll finally get to the point where we can't simplify anymore, and we'll solve it. Okay? So far, so good? All right, that first one, evaluating an expression. What's an expression? Really layman's terms, an expression is just a bunch of stuff added together. Okay, the book will give us a real formal definition, but stuff added together, for an example, 2x plus 5, some things added together there, we call those things terms. So an expression is going to be terms added together. And there's two varieties of terms we're going to be dealing with. Okay, if we've got a letter in there, like the 2x, we call that a variable term. Okay, and if it's just a regular old number, a 5 is a 5, is always a 5, it remains constant at the value of 5, we call that a constant term. Okay, variable terms and constant terms added together make up an expression. The variable terms always have two parts. There's this number out front, which we call the coefficient. Okay, and then the letter itself we call the variable. Okay, coefficient out front, variable. There's always two parts to a variable term. There's right side by side a number and a letter. Coefficient and variable. Now, what's the relationship between that coefficient and that variable? There's something happening there. Remember that x represents some number, some actual number. So it's 2 side by side with some actual number, but I don't know what the number is right now, so I call it x. 2 and an x side by side. They're doing something with one another. There's a mathematical process at work there. Anybody know what it is? In other words, am I talking 2 plus x? 2 minus x, 2 times x, 2 divided by x. It's one of those 4. Which one is it? It's 2 times x, right? 2 times x. Now, I forgot my x-ray glasses tonight, but I don't see a times sign in there, do you? Where's the times sign? It's not there. In algebra, there's a lot of different ways to show times, and we got to start getting used to this now. The way we're most familiar with from arithmetic, good old 2 times 3, the classic times sign, guess what? We're not going to use that classic times sign in this class. And why do you suppose that is? It's because we don't want to confuse the times sign x with the variable x. Now I always make a times sign x very plain x, and I always make a variable x like a cursive x, but that's just my style. There's no convention that it has to be that way. So all these x's could be confusing. So we get rid of the classic times sign. There's a lot of other ways to show times, one of which is a dot, a big dot in the middle, 2 times 3. I'll use the dot, but I'm not a huge fan, and the reason is if you get a little sloppy and careless and make the dot a little too small and a little too low, it looks like the decimal 2.3 instead of 2 times 3. Okay, so we need to be careful. The book doesn't mention the star character, and we won't use it in practice on the board, but just to throw it in here, that's what your computer uses, right? The star key for times. The one we're going to use really big are parentheses. If I put the 2 down here, and then I open up a parentheses and put the 3 inside, or if I put the 2 in parentheses with the 3 next to it, or if I put them both in parentheses. Every one of those things is the same thing, 2 times 3. Just shown differently, okay? We need to get used to that. But here's what I can't do with just a 2 and a 3, and I can't just slap them side by side and expect you to think that means 2 times 3, because that's a 23. See, but with a 2 and an x, there's no confusion. Okay, with the 23, or with the 2 and the 3, I have to do something. With the 2 and the x, I don't have to do something, because there's no confusion there. Or an x and a y. I don't have to do something. So a number and a letter side by side, or 2 letters side by side, it means times without a times sign. Okay, but now, let's say, hey, 2x is the problem at hand, which means 2 times x. I want you to put a value to that 2 times x. If I tell you what x is, remember our first choice here. Someone's going to tell me what x is, and I'm going to put a value to this guy. Okay, so I'm going to say x is 7. I'm just pulling numbers out of the air. Put a value to 2x if x is 7. Well, that means I'm putting a 7 in place of that x, like that. But that's a 27, and that's not what I'm asked to do. I'm asked to take 2 times x, which means 2 times 7, which means a times sign, and I'll always favor those parentheses. It's not 27, it's of course 14. Okay, we need to quite often put parentheses in where we did not have them before. Okay? So that's the variable term. It always has those 2 parts, a coefficient and the variable itself, side by side, hand in hand. Is there anything on the board that I've written tonight that might contradict what I've said a couple of times now? I'll say it once more. Variable terms always have 2 parts, a coefficient, which is the number out front, and the variable itself. Anybody see a problem up there? Well, what's the first thing I wrote down here tonight? Well, 2 plus 3 was the first thing, but what was the next thing? X plus 3. There's no coefficient on my x there. Did I already make a mistake? X plus 3 doesn't have a coefficient. Or does it? It does. It's hiding. What's the coefficient on that x? I just didn't write it. It's there. I guarantee everybody's thinking it's either a 0 or a 1, right? Those are kind of the 2 choices. Remember, it's a relationship of multiplication. If it were a 0, that means it's 0 times x. Well, we know that 0 times 5 is 0. We know that 0 times 10 is 0. So that would mean 0 times x is 0. So I don't think it's a 0, right? Or that wipes out the whole term. What about a 1? 1 times 5? Aha! Still a 5. 1 times 10 is still a 10. Guess what 1 times x is? Still an x. Okay? We need to get very comfortable with these 2 things being the same because they are the same. Okay? 1 times x is still an x. I can write it with the coefficient of 1, or I can not write the coefficient of 1. Generally speaking, we don't write things that aren't necessary, and it's not necessary. But it wouldn't be wrong to write it. If you want to write 1x plus 3 instead of x plus 3, I'll never tell you it's wrong. I'll just tell you that most of the time the book won't show it. Sometimes it will, sometimes I will, but we just have to really understand that it's there. Okay? There's a multiplication relationship there, and when you're multiplying something by 1, it's the same value, so it's unnecessary to write that 1. Okay, let's dive into the book and see what it has to say. It'll give us a little more formal definition of expression, and then we'll do a bunch of evaluating of expressions. We'll get a little more complicated. We'll take a first look at something called order of operations, and then we'll discuss the difference between expressions and equations. Thank you for watching. That was a quick little introduction. I take it from there, and we dive into the book and have lots of fun in this course. Thank you.